All right, so today we are going to take a look at section 3.8, which talks about how to transform polynomials. So if your warm-up is blank, you lost a learning opportunity. So here's your answers. You can get those from online. Those are available online. Yes.
For the second one, when I put it in the graph I got, actually that looks familiar, but why is it just kind of like one loop, even though
Yeah, so it doesn't have a maximum. That's just the behavior of the graph. It kind of just curves, but it never has a bump to it. So
I did actually get it right.
Yeah, so there is no bump that is a maximum. Very good observation. See, learning opportunity. That's why those warm-ups are there, not just to take up space. All right, so do this. See why there is no maximum there. All right, we learned back in Unit 2 how to transform polynomials. Today we're going to transform, we transform quadratics. And today we're going to transform polynomials, which is much more mathematically intense. All right. People in first period were like, why is this so hard? Okay. So I suggest pay attention. So let's review how we did it with quadratics, which were actually fairly easy. If I want to compress this vertically by a factor of 1/2, that's my A is 1/2. Translate right 3 units, that's H, so it's going to be X minus 3. And down 5 units, so K is going to be -5. And we've got our transformed quadratic. Now, when we do polynomials, it gets to be, like I said, mathematically pretty intense. We have to really pay attention to what's going on with the polynomial. But we're going to graph some on the calculator to verify what we're looking at. So I am going to switch my view here. Okay. So this kind of looks familiar because this is what we did back in Unit 1 and Unit 2. I told you then that we were going to use it all year long, so pay attention to that then. This, our vertical translation, I'm going to take the whole function and move it up or down k units. Horizontal translation, remember it's inside the parentheses there, it's inside the function. I'm going to just manipulate the x value, h units, if h is, so it's x minus h. So if h is positive to the right, it looks something like x minus 2. If h is negative, translating to the left, it'll be x minus 1. A vertical stretch or compression is outside the function. We're going to apply it to the whole function. So I have a times f of x. So if I want to stretch the whole function, x cubed, by a factor of 6, it'll look like 6x cubed. If I want to squish it in half, vertically compress it, it will be a factor of 1/2. And again, we're going to multiply that by x cubed. Now, if I want to do a horizontal stretch or compression, we're going to apply it to the x within the function. And it's going to be the reciprocal. That's one that just kind of takes, you got to just kind of get used to it. So if I want to compress this by 1/3, b is equal to 1/3. 1 over 1/3 is equal to 3. If I want to stretch it by a factor of 5, b is equal to 5, it's going to be 1/5. So inside, you got to think opposite, right? Outside, it's going to be the same, but inside, you got to think opposite. We're going to look at reflecting today. If I'm going to reflect across the x-axis, I'm going to take the whole function and flip it over. If I'm going to flip across the y-axis, I'm just going to change my x values inside the function. I'm going to negate them. We're going to look at examples of all these. And again, it gets to be a little bit mathematically intense. So let's start with one that's not too hard. I have a function x cubed, f of x equals x cubed minus 6. I want to write the rule for the function and graph g of x using this axis. I'll do it on the calculator over here. And describe the transformation. So here, I'm just going to take f of x. I'm going to move the whole thing up 2 units. Not too hard, because this one, f of x, we said was equal to x cubed minus 6. And we're going to move it up 2. So my g of x, simplifying, looks like x cubed minus 4. So just what does this look like on a calculator? Let's let me share my calculator here. And so I'm going to go to my y equals screen and clear out anything that's already there. My plots are off. And my f of x is x cubed minus, oops, not, x cubed, make sure I get it right here, minus 6. And if I graph this, I would expect a cubic function that's 6 units below the x-axis, right there. Oh, why did I do it in red? I don't know. G of x is going to be x cubed minus 4. Let me put this one up here. X cubed minus 6. And then down here, I'll do this one, x cubed minus 4. And my blue one is my f of x, which is shown here. And my red one is going to be 2 units above that. Not too exciting. Kind of what we would expect. All right. So that's not too exciting. So let's try something a little bit harder. Yes.
So that is one in the parentheses is opposite. So why is it not x cubed plus 6?
X cubed minus 6. We're just taking the function as it's written.
Oh, okay.
Okay. So we're just substituting x cubed minus 6 for f of x, and then we're adding 2 to it. Okay. Yes.
What are we trying to take out of that?
What we're doing graphing is that we are making sure that the transformation is what we expect. Okay, so I expect g of x, my red function, to be 2 units above f of x, my blue function. This example is pretty easy. Okay, it doesn't stay easy. Okay, so let's try another example. Let's try another example here where I've got the same f of x, but now I want to shift it horizontally to the left 3 units. This gets to be a little tricky because what's happening here, I'm going to replace x plus 3 for the x in f of x. So my g of x equals the quantity x plus 3 cubed minus 6. I could graph that, but that's not in standard notation, right? I need to put my polynomial in standard notation. This is a little tricky. This, my friends, is a binomial expansion. I was surprised how many people did not do that on the quiz. They chose to multiply it out, which takes about 5 times as long. Okay? Know your binomial expansions. It'll save you. You should have done that problem in 30 seconds. Okay? With the binomial expansion. My binomial expansion is going to look like this. My x term goes x cubed, x squared, x to the 0. My 3 term goes 3 to the 0, 3 to the first, 3 squared, 3 cubed. My Pascal's number, 1, 3, 3, 1. And the -6 or -6 is coming along for the right on the outside. All right, so let's write this. X cubed plus 9x squared plus 27 x plus 27 minus 1 is plus 21. So now I have my polynomial in standard form, and it looks nothing like my f of x. But when we graph it, let's see what happens. Y equals, we can get rid of this second one here. And let's write my new function here. G of x is x cubed plus 9x squared plus 27x. Oops, I hit the wrong button there. Plus 27x plus 21. And now if I graph this, if I click graph, that would help. There is, oh, I got to share my screen. All right, hang on. Let me try that again. All right, I thought I had something else there. So my function, my f of x is x cubed minus 6. My g of x is x cubed plus 9x squared plus 27x plus 21. And if I graph this, my f of x is in blue and my g of x is in red. And sure enough, it's moved 3 units to the left. Yes. Yeah, but you don't know what the standard form of G is. That's what we're trying to figure out. What is the standard form of the polynomial that's 3 units to the left of f of x? And you might say, well, what's the point of that? And the point is that it's learning the behavior of polynomials, okay? Yeah, I could have just plugged in this. If I were to graph that, y equals, and if let's just do in green down here. Let's say I just said, well, I'm just going to do it the easy way. I'm just going to say x plus 3, that quantity cubed. And now I'm going to add 21. I'm sorry, subtract 6. Let's look at the wrong line there. Minus 6. This is going to graph right over my red function here. But I want to know, okay, well, that's nice, but what is it in standard form? Okay, so it gets to be a little bit tricky. All right, let's so let's take a look at another example. Another 2 examples. Here I've got a different f of x, so we'll type that in a second. Write a function g that performs each transformation. I want to reflect f of x across the x-axis. So I'm just going to take the entire function and negate the whole thing. So this isn't too tricky. If this is my f of x, I'm just going to negate the whole thing. The only thing I need to do to put this in standard form is distribute that negative through. So that's pretty easy. Let's take a look at what that would look like on our calculators. So let's clear these guys out. Clear and clear. And my f of x is x cubed plus 5x squared minus 8x plus 1. Make sure I got that right. X cubed plus 5x squared minus 8x plus 1. That looks good. If I were to graph this as some sort of cubic function, and it kind of goes off the screen, but we see one dip there, so that's good enough for what we want to do. And now imagine I'm going to take that thing and just mirror image across the x-axis. So let's plug that in as my y2, and I'm just going to simply change all the signs. Negative x cubed minus 5x squared plus 8x minus 1. And if I graph this, my red should be just a mirror image across the the x-axis, and it'd be blue, right? So that's not too hard. This one is a little trickier, but still not too bad. Let's take a look at the next example here. And that, what do I have? I've got g of x is equal to f of negative x. So I'm going to negate each x inside the polynomial, and this will flip it across the y-axis. So what in effect happens, I've got negative x cubed, so I'm going to change this guy's sign, but negative x squared is the same as x squared. And negative 8 times negative x, we're going to change that sign, and the plus 1, the constant, stays the same. So in effect, I'm just changing the signs of the x cubed term and changing the sign of the x term. Well, what is that going to end up looking like? And I'll do this one on the same graph so we can see the difference here. Yes, question. Sure. So let's take a look at y equals, and this one I'll do on the same graph. I'll do it in green so we can see it. G of x is going to equal negative x cubed plus 5x squared, so the x squared term stays positive. But now the negative 8x becomes positive 8x. And plus 1 stays the same. So now I would expect when I graph this, it is going to be reflected across the y-axis. So, and indeed, it is the blue reflected across the y-axis. It's a little bit confusing there, but you can see the red is a reflection across the x-axis. The green is a reflection across the y-axis. And that's from these two equations. I probably should have called this something other than g, because this is g, this should be h of x or something. Oh, well. So now let's get into the compression and stretching. This gets to be a little bit trickier still, right? So we got to be a little bit careful with what we're doing. So I'm going to start with an f of x of 2x to the fourth minus 6x squared plus 1. What that represents, I don't really know, but it's going to be a quartic function, so I'm expecting, and it's positive, leading coefficient positive. So I'm expecting some sort of W shape. We'll see if we get that. And then I want to compress it in half. So I'm going to take the entire function and multiply by 1/2. So what's that going to look like mathematically? I'm going to take the whole function and cut it in half. So I've got x to the fourth minus 3x squared plus 1/2. Now let's graph that and see what it looks like. So I'll go to my y equals. Let's get rid of all these. So these aren't in the way. And let's go back to my y1. We'll do that as my f of x. This is a 2x to the fourth. There is no x cubed term or x to the first power term, but I don't care right now. Oops, what am I doing? Y equals, let me try to see it, 2 x to the fourth minus 6x squared, and then plus 1. So let's just graph this just to kind of see what it looks like. Some sort of quartic function. It should be W-shaped or something. There it is. Okay. So we have a nice, good-looking W there. Now, I want to take the function that is going to be compressed in half. So y equals, here I've got x to the fourth minus 3x squared, and then plus 1/2. I'll just call that 0.5. And graph that, and my red function should be the blue one just squished in half. And indeed it is. You'll notice that my max here looked like 1. So on my red function, my max looks like 1/2. Here, these mins look like 1, 2, 3, about 3.5 or so. And so my mins on the red look like about 1 3/4. So it's half as much what I expected. All right, now let's try. What is this? This is a stretch of 3 horizontally. So I need to take each of my x terms and substitute 1/3 x. So what's that going to look like? I've got 2 times 1/3 x to the fourth minus 6 times 1/3 x squared plus 1. Again, I could type that in, but that's not in standard form. Standard form is going to look like this. 2/81 x to the fourth minus 2/3 x squared plus 1. Let's compare that to my f of x and see what it looks like. Well, I'm going to get rid of this one because it's kind of cluttering things up. So let's replace it with this one. 2/81. And I'm just going to put parentheses around it because that makes me feel better. You don't have to, but it makes me make sure that I did it right. X to the fourth minus 2/3 x squared. And then I've got plus 1. And I would expect this W to be 3 times wider than the blue W. And indeed it is. It's got the same local min, and my local max values are the same. It's just that now it's wider. So I didn't compress it this way at all. I just took the whole thing and stretched it out this way. All right, now it gets real fun because we're gonna do more than one transformation and see what the resulting graph looks like. So here I've got an f of x, pretty simple function, 3x cubed minus 3. I want to compress vertically by 1/3, which means it's going to be on the outside of the function, multiplied by the whole function, and then shift 2 units to the right. Oh, wait, that's got to be on the inside of the function. So what's my function going to look like? It's going to be 1/3 f of x minus 2. So now I got to take x minus 2, substitute it in here, and then take that multiplied by 1/3. So I've got 6 times x minus 2 cubed minus 3. Oh, and then I'm going to compress it into by 1/3. So I need to multiply that whole thing by 1/3. Now we have to do a little bit of math. So x cubed, x squared, x to the 0th, negative 2 to the 0th, negative 2 to the first, negative 2 squared, negative 2 cubed, 1, 3, 3, 1 by Pascal's number. But I'm going to take that whole thing and multiply it by 6 divided by 3, which is 2. And then 1/3 times 3 is, times negative 3 is minus 1. So that's where that came along for the ride. But my binomial expansion is this section right there inside the parentheses. Now I got to combine like terms. So I've got, still got my 2 out there, x cubed minus 6x squared plus 12x minus 8, and then minus 1. Almost done. 2x cubed minus 12x squared plus 24x minus 16 minus 1 is minus 17. Yes.
So the 2 and the negative 1 in the third equation, you got that from multiplying 1/3 by both of them.
Yes. Yes. So I distributed the 1/3 across. That's correct.
Did you distribute the 1/3 into the x?
Well, no, it just because it's multiplied by this 6. So I just needed to multiply 1/3 times 6.
Oh, okay.
And then 1/3 times negative 3. So let's graph this and see what we're looking at. Let's clear these guys out. We don't need these anymore. Oh, and so I got actually 6x cubed minus 3. That looks good. If I graph that, it should be some cubic function. That's 3 units below. Yeah, that looks right. Now, this looks nothing like what I started with, does it? Other than the fact that it's still cubic. That's about all. So let's graph this one. And it is 2x cubed minus 12x squared plus 24x minus 17. Make sure we got that in correctly. 2x cubed minus 12x squared plus 24x minus 17. That looks good. Now, I expect this to be compressed by 1/3 and then shifted right 2 units. So there's my f of x, my g of x, compressed by 1/3 and shifted to the right 2 units. So this spread was compressed. My transition point here was at y equals -3. Now I've got y equals -1. So it's been compressed by 1/3 and shifted over to the right 2 units. Doesn't look anything like what we started with, but they are related. Okay. So again, understanding the behavior is the goal here. Seems like a lot of busy work, but the more you understand about polynomial behavior, the easier calculus will be for you. All right, let's try another one here. I'm going to use the same f of x, but I want to reflect across the y-axis and shift 2 units down. So let's rewrite this. If I'm shifting across the y-axis, that means I'm just changing the x inside of the function. And then I'm going to shift 2 units down, so -2. Let's take our f of x and substitute negative x in. That's 6 times negative x cubed minus 3 minus 2. So rewriting this in standard form isn't too hard. Negative 6x to the third minus 3 minus 2 is -5. So these actually kind of do look alike. Sometimes they do, sometimes they don't. So my y of x, f of x is still the same. But now let's put in my new g of x. Let's clear this one out. And it's simply negative 6x cubed minus 5. And if I graph this one, I expect it to be flipped across the y-axis and down 2. And it is flipped across the y-axis. Great. What would life be without one for you to try? All right, I'll give you a couple minutes to look at this one. I apologize that I didn't give you much room to work. So if you need another piece of paper, you might want to do that. But in about 1 minute, I'll give you the first step. I think you can come up with the first step. Yes. Yeah. It's so for this one, here, let me give you the first 2 steps here. Here I've got my f of x is 8x cubed minus 2. I want to stretch vertically by a factor of 2. So I'm going to take all of f of x and multiply it by 2. So I'm going to put the 2 in front of f of x. I want to shift to the left 3 units. That is changing my x value inside the function. And I'm going to shift it to the left 3 units, which means h is -3. So it's going to be x plus 3. And then the last thing, I'm going to shift up 4 units. So after it, I'm going to add 4 units. So my first step is I'm going to take the whole function. I'm going to replace x with x plus 3, shifting it 3 units to the left. I'm going to multiply it by 2 to stretch it, and then I'm going to shift it down 4 units. So before you get too far on the wrong track, what is this going to look like then? I need to take the x plus 3 and substitute it into my f of x. So I've got 8 times x plus 3 cubed minus 2. That whole thing stretched by 2 and then moved up 4. That is a binomial expansion. Or this heck book. Give you a clue, these numbers get a little bit big. That's bigger than you might expect. Give you another minute. All right, if you were struggling with your binomial expansion there, first thing I did was distribute this 2 across. So I've got 16 x plus 3 cubed minus 4. Oh, plus 4. That's convenient. Those go away then. And what am I left with? 16 times this binomial expansion. X cubed, x squared, x to the 0, 3 to the 0, 3 squared, 3 cubed. Pascal's number, 1331. Just multiply those out. And what do you get? 16x cubed. 16 times 9 is 144 squared. 16 times 27 turns out to be 482. So this doesn't look a whole lot like what we started with. But let's take a look at what it looks like with a calculator. So my y equals is 8 x cubed minus 2. And my resulting equation turns out to be 16x cubed plus 144 x squared plus 432x plus 432. And let's graph those and see what we get. So there's my f of x. And now it should be stretched vertically by a factor of 2. Shifted to the left 3 units and up 4. So if this was stretched vertically by a factor of 2, my transition point would be down here at y equals -4. And then we shift over 4 to the left. I'm sorry, 3 to the left and up 4 will put us right on the x-axis. So indeed, it does look correct. All right. Let's try the next one. It's the same f of x. But now reflected across the x-axis, which means we're going to negate the entire function. Shift 4 units to the right, which means my h is +4, so it's going to be f of x minus 4. And then on the outside is going to be -1. Yes. What's there to memorize? Just we've been doing it all year. If you go back to that first or second slide, the same thing we did with quadratics. It's just now it's a little bit more involved because we have to put it in standard form. Do you need to memorize the transitions? Yes. So study that slide, the second slide or whatever that had all the transitions. But again, shifting to the left or right, those are the same things we've been doing since Unit 1. Shifting up and down, same thing we've been doing since Unit 1. We're doing a little bit more with compression and reflection now, but once you get it, it's not too hard. So again, I'm going to take the entire function. I'm going to take the entire function and negate it, but I have to shift 4 units to the right, so that's going to be x minus h, x minus 4, and then my k is -1. So I'm going to substitute for x, I'm going to substitute x minus 4. And then I'm going to have to do a binomial expansion. So what's this going to look like? My function is 8x cubed minus 2. So it's 8. I'm going to substitute x minus 4 for x. So x minus 4 cubed minus 2. Negate the whole thing and then subtract 1. So let's do that binomial expansion. Okay, it's going to be x to the third, x squared, x to the 0. It's going to be -4 to the 0, -4 squared, -4 cubed, 1331. X cubed, x squared, x to the first, x to the 0, -4 to the 0, -4 squared, -4 cubed, And my Pascal's number, 1331. Then I've got an 8 that I'm multiplying through there. And then I'm going to subtract 2, negate the whole thing, and then subtract 1. So let's combine like terms. What do I have? Negative, I've got 8x cubed. I'm going to negate that, negative 8x cubed. I've got 24 times negative 4 is negative 96 times, and I'm going to negate that, so it's positive 96 x squared. I've got 8 times 3 times 16 is 384. I'm going to negate that, so negative 384x. Negative 4 cubed is negative 216. I'm sorry, negative 64 times 8 is 512 plus 2, because it's minus 2. So it's 514 minus 1 is 513. So let's graph this and see what it looks like. And if you're a math nerd like me, you actually think this stuff's kind of fun. If this is torture, you're in the wrong place, because we're going to be torturing you all year. So my f of x is still the same? Yes. Question. This 8 times 64 turns out to be 512. And then I'm adding 2, because it's negative 2, so that's 514 minus this 1, which was my shift down 1 unit. That's what that turned out to be. So you just got to make sure you do the math right. So let's try plugging this in to my second equation here. So I've got negative 8x cubed plus 96x squared minus 384x plus 513. So now what do I expect? I've got my f of x, and I expect it to be reflected across the x-axis, shifted 4 units to the right, and down 1. Okay, so f of x flipped over the x-axis, shifted 4 units right and down 1. Let's see if we actually indeed did that. There's my f of x. I expect it to be shifted across the x-axis, over to the right 4 and down 1. So if this was shifted across the x-axis, this would be at positive 2. Shifted over 1, 2, 3, 4, and down 1. My transition point is now at 4, 1. It looks right. Looks right. All right, the next one is just a simple word problem. I know word problems sometimes seem intimidating, but this is actually a lot easier than what we've been doing. And that is the number of skateboards sold per month can be modeled by this equation. Now, if x represents the number of months, so that's my input, my output is the number of skateboards, right? And I want to just add 20 to it. So this isn't so hard. I'm just going to take my f of x and add 20 to it. So my g of x is just my same equation, but I'm adding 130 plus 20, 150, instead of just 130. What does this mean? I can expect to sell 20 more skateboards per month. Not that difficult, right? All right, I'll come back to the previous slide in a second here. All right, your homework is listed out there. Here's your Alex topics you're going to be expected to know by the test. So if you're having trouble with some of these things, the Alex topics. All right, we have about 7 minutes. Yeah. There was no maximum. Yeah, so you can't quite see it there, but what's happening is it kind of trends. No. It's a little flatter than middle C now. And then it's down. So there is definitely a minimum, but there is no bump. It's a transition, but it's not a bump. So there is no maximum. Yeah, so we got 1, 2, 3 transitions, right? So this is curving this way, that curves this way, curves this way. So there are 3 transitions. It's just not like this, right? Where I've got a minimum and a maximum, right? This kind of got flattened out, so there was no extra minimum and maximum. So there are transitions, but they're just not maximum. So you're not able to do it? I was not able to. And the airplane doors had shut, the plane had already taken off. So you were left at the airport. Yeah. You had your ticket in your hand, right? That means you gotta catch another flight, right? Okay, I'm not gonna accept email homework, that's what the submission is, okay? But I don't have time to go through my emails and see what students turned in this set, okay? So, I'll check my email now and for the quarter, I'll update it. But don't get in the habit of doing that because I don't have time to collect homework by you. Okay? I still got submission. All right, hold on. 3.6? I think it actually is open. You're not the only person that is recording. All right, Dr. Shim next year won't take late work. Okay? Let's get used to it.